Hello student friends, morning all of you. Now in this class, we are going to discuss the new topic, namely sulphonation of benzene. In the last class, we had a discussion on nitration of benzene. That is, benzene when treated with a mixture of nitric acid concentrated and concentrated sulfuric acid at around 60 degrees Celsius. The product what we get is nitrobenzene, yellow in color. Simplest method of making nitrobenzene. The mechanism of nitration of benzene, different steps involved in the mechanism of nitrobenzene, everything we have discussed in the last class. Today the discussion is about sulphonation of benzene. Similar to nitration of benzene, sulphonation of benzene also an electrophilic substitution reaction. In the case of nitration of benzene, the electrophile involved in substitution is nothing but NO2 plus. In the case of sulphonation, the case is different. This we are going to discuss. So under this sulphonation of benzene, we are going to discuss what is sulphonation, how to carry out the sulphonation reaction, the mechanism of sulphonation, different steps involved in the mechanism of sulphonation of benzene we are going to discuss. The topic is sulphonation of benzene, or simply sulphonation. Sulphonation of benzene. In sulphonation, we can carry out this particular sulphonation of benzene in two different ways. Number one, when benzene is treated with concentrated sulfuric acid at around 80 degrees Celsius, around 120 degrees Celsius, you will get benzene sulfonic acid, one method. So the method number one is benzene on treatment with concentrated sulfuric acid. The product what we get is benzene sulfonic acid. The temperature required to carry out this particular conversion is 120 degrees C. The second method is same product, but the condition is little different. Nothing but when benzene is treated with a fuming sulfuric acid, we get same product, benzene sulfonic acid, but the temperature is not that much required. Simply on heating at room temperature is enough to convert the benzene into benzene sulfonic acid when the reagent is fuming sulfuric acid. What is fuming sulfuric acid? Nothing but a mixture of concentrated sulfuric acid and sulfur trioxide. This combination is fuming sulfuric acid. I repeat, fuming sulfuric acid is a mixture of concentrated sulfuric acid and sulfur trioxide. Benzene when treated with method number one, concentrated sulfuric acid at around 120 degrees Celsius. Method number two is benzene treated with fuming sulfuric acid. Fuming sulfuric acid. This you get SO3H. This is benzene sulfonic acid. Here also the same product. So the final product, benzene sulfonic acid, you can prepare into different ways. One is by heating the benzene with concentrated sulfuric acid at 120 degrees Celsius. The product is benzene sulfonic acid. The second method is benzene when treated with a fuming sulfuric acid at ordinary temperature, that is at room temperature. The product is same, benzene sulfonic acid. I told you that this is nothing but a mixture of concentrated sulfuric acid plus sulfur trioxide. This combination is nothing but fuming sulfuric acid. This combination is nothing but fuming sulfuric acid. Are you clear? Benzene, in this sulfonation reaction, we are treating benzene with concentrated sulfuric acid or with the fuming sulfuric acid. The temperature is different. When sulfuric acid we use, the temperature is 120. When we use a fuming sulfuric acid, the temperature is just room temperature. The product remains same, that is benzene sulfonic acid. Now fuming sulfuric acid is nothing but a mixture of concentrated sulfuric acid and sulfur trioxide. Sulfur trioxide. So this is about what is sulfonation of your benzene. Now we are going to discuss the mechanism behind this particular sulfonation of benzene. Mechanism of sulfonation. We see that there is a whiteboard. If there is any problem in the clarity of this board, please let me know the defects, whatever I have while teaching this, while uploading this, let me know. I'll try to rectify in my next class. Anyway, this is about your sulfonation of benzene. Are you clear? See again. Yes, I'm going to delete this. I'm entering now this mechanism of sulfonation. Mechanism of sulfonation. The concept is mechanism of sulfonation. Similar to the nitration, the previous electrophilic substitution reaction, sulfonation also involves 3 different steps. Number 1, as usual, formation of an electrophile. Electrophile is nothing but a species, attacking reagent, attacking one that carries positive charge. This is your step number 1. And in step number 2, the attacking of this electrophile, positively charged species, into an aromatic system takes place, followed by your delocalization of pi electrons, thereby stability reaching, everything takes place. And in step number 3, the final product we get. These are the 3 different steps. I'll explain the 3 different steps involved in step number 1. Step number 1 is a simple formation of an electrophile. Take 2 molecules of sulfuric acid, gives you, in an equilibrium reaction, gives you SO3 plus H3O plus, then we have HSO4 minus. These are the 3 things we get in step number 1. Number 1, 2 molecules of sulfuric acid in an equilibrium reaction gives you sulfur trioxide, H3O plus and HSO4 minus. Out of this sulfur trioxide is our electrophile. Sulfur trioxide is our electrophile. You can ask me that there is no plus charge here. How can this sulfur trioxide act as an electrophile in this reaction? I'll explain you the answer for this. Anyway, this is our electrophile H3O plus HSO4 minus. Now come to step number 2. Benzene we have as usual. Yes, we have sulfur trioxide. This is the original, the structure of your sulfur trioxide. This comes here and this approaches this one. In the meantime, this goes here. You will get this plus charge developed here. Here SO3 minus, and here the proton remain. Yes. And in step number 3, SO3 minus H. This will be removed and goes to HSO4 minus. This comes here. The product is SO3 minus remain. This SO3 minus then takes the proton from H3O plus, converting this into benzene sulfonic acid, SO3H. Simple. Yes, these are the few steps involved in the sulphonation of benzene. I repeat, the mechanism is step number 1. In step number 1, sulfuric acid will be converted into an equilibrium reaction, converted into sulfur trioxide plus H3O plus HSO4 minus. This particular sulfur trioxide is going to act as an electrophile in this particular reaction. How this electrophile attacks the benzene, we will discuss in the second step. Second step, benzene is here. This is the structure of sulfur trioxide. At the moment of approaching this sulfur trioxide into benzene, that is, when the sulfur trioxide reaches close to benzene, the benzene will adjust its pi bonding electron in such a way that there will be development of your negative charge here. And when the minus charge is developed, the sulfur trioxide adjusts its pi bonding electron like this, so that the sulfur acquires now the positive charge. The positively charged sulfur connects with the negative end of your benzene. There will be a formation of a permanent bond. And because of this pi bond electron moved over your oxygen, the oxygen acquire now the minus charge. We know very well, compared to sulfur, oxygen is electronegative. Therefore, this pi bonding electron moved towards oxygen, not towards sulfur, making the sulfur positively charged. I repeat, because of the electronegativity difference, the oxygen acquired, that is, pulls the electron, the pi bonding electron moved close to oxygen, over oxygen, making the sulfur positively bond. This positive end of your sulfur connects with the negative end of your benzene. There will be a formation of CSO3 minus. And in step number 3, we have in the medium, from the first step, what are the things formed? One is sulfur trioxide that involved in the electrophilic attack. Second is H3O plus, and the final one is HSO4 minus. The HSO4 minus species attracts the proton without its bonding electron, and this HSO4 minus as a result will be converted into H2SO4, minus H2SO4. Leaving this bonding electron, CH bonding electron remain here. This will come immediately into the circulation, that is delocalization. As a result, this will be converted into pure benzene. SO3 minus remain. This SO3 minus in the final step takes one proton from H3O plus, converting this H3O plus into water, and the proton connects with SO3, converting this into SO3H. This is the final product. This is benzene sulfonic acid. Are you clear? The mechanism is very simple. Have a look. Have a look. This, I don't find any difficulty in understanding this particular mechanism, particular sulfonation reaction similar to nitration. This is very simple. Again, have a look. Yes, I am concluding with this mechanism today's session. I'll try to upload very shortly. If there is any problem in understanding this particular mechanism or understanding the concept of this sulfonation, you can feel free to ask me at any time via my YouTube channel or via the Google Classroom. Yes, I'm closing this session. Thank you. Thank you then. Thanks for watching my videos. Thank you.